Hi, everybody. So this is the last of the new material before our assessment for Trig Basics. This is assignment number 12. And mostly I'd like to just sort of practice some things for half of our class, and I'd like to do some, what would be in the classroom whiteboard practice with you. Okay, so that's very interesting. Oh yeah, gotta do those. Okay, so let's start with some basic solving. Okay, and we're looking for solutions on 0 to 2 pi. Now, look at this notation. This means 0 is included, and this means 2 pi is not included. So the answer, because when I think about here on the unit circle, I have 0, but that's also called 2 pi. Like I start here at 0, and I end at that same place, but we call it 2 pi. Well, we're not going to write down both of them. We're only going to write down 0 and not 2 pi. Okay, so what do I mean by solving? Well, I mean to start real gentle. I mean sine theta equals 1/2. Okay, so when does the y value, what angle has a y value of 1/2 on the unit circle? From 0 to 2 pi. So when is that? Well, I know that happens twice. Sine is positive 1/2 twice. Once over here at pi over 6. Where's the other one? That's right, sine is positive in these quadrants. So there must be one over here. What angle is this angle? Well, we know that not only is theta pi over 6 for this one, but theta is 5 pi over 6. These are the two places on the unit circle where the y value would be 1/2. Okay? In general, I expect two solutions here. Sometimes, though, we only have one solution. Like if I had asked, hey, sine of theta is -1. Well, if the sine of theta is -1, that only happens in one place, here, where the ordered pair is 0, -1. And so we must be talking about theta equals 3 pi over 2. But aside from quadrant angles, like 3 pi over 2, or pi over 2, or pi, or even our friend 0, because 2 pi isn't included, quadrant angle solutions, I'll only have one of them. But for all others, yeah, I'm expecting two solutions. So think about your unit circle. Sine of theta equals -√3 over 2. What's theta equal to? 5, 4, 3, 2, 1. Well, sine is negative twice. Once in third quadrant, so theta would be 4 pi over 3. And a second time in fourth quadrant, 5 pi over 3. If I don't have my unit circle memorized, really memorized, I'm probably not going to have an easy time coming up with these answers. Okay? So, what about this one? What about cosine theta equals -√2 over 2? 5, 4, 3, 2, 1. Okay, so when is cosine √2 over 2? Oh, -√2 over 2. Cosine is negative in second quadrant and third quadrant. So where is the x value? -√2 over 2. That happens when theta is 3 pi over 4 and when theta is 5 pi over 4. These are the two places where cosine would be -√2 over 2. Okay, how about this one? Cosine theta equals 1/2. 5. No, really, you should know this that well. So the x value is 1/2. 4, 3, 2, 1. You should have come up with pi over 3. When else is cosine positive? Oh yeah, in fourth quadrant, 5 pi over 3. Okay, how about this one? Sine of theta equals negative root 3 over 2. 5. Oh wait, I did that one. Let's do positive root 3 over 2. 5, 4, 3, 2, 1. You should have come up with pi over 3 and 2 pi over 3. These are places where the y value is positive root 3 over 2. What if I have something like cosine theta equals negative 1? What do you mean you don't know what to do with that? What angle has an x value of negative 1? What's the angle here? That's right. Theta is pi. I know there aren't two solutions to all of these. When we're talking about a quadrant angle, we're only going to get one solution. Okay? Only one solution. Fabulous. So, can you do one? Can you do another? Can you? How about this one? How about cosine of theta equals 0? Okay. Hey, how did it go? Did you come up with the fact that the x value is 0 actually in two places? One of them is at pi over 2, and the other is at 3 pi over 2. Huh, so it's not even all terminal. I mean, it's not even all quadrant angles where this is a situation, i.e. I only get one answer. Yeah, it only seems like when the trig function is negative 1 and that trig function is sine or cosine. So most of the time, we're going to have two solutions. But again, this is only just a little dabbling in solving. We have a whole unit dealing with trig identity problems and solving. Yeah, so you'll get lots of practice with that in the near future. For now, though, I'd like to look at how I could do this problem. Sine of theta equals 0.4. And again, I'm looking for solutions on 0 to 2 pi. And I agree. I don't recognize this from the unit circle. And that's okay. I'm going to show you how to use the magic box to help figure out when sine is equal to 0.4. Okay? Now, algebraically, what I'm going to do is I'm going to take the inverse sine of both sides and cancel, and I get theta equals inverse sine of 0.4. All right, well, inverse sine of 0.4. And, ooh, I want radians. So let's check that mode. Not degrees. Phew, I almost made a mistake there. And so what do I get? I get 0.4115 or 0.412. Okay, so theta is 0.412. Isn't that great? Yeah, no. Why not? Because we know sine is positive in first quadrant and in second quadrant. There should be two solutions here. Uh-oh. So we're saying that this angle is 0.412 here, but we need to also find this one. Huh. That seems awkward. Well, here's an interesting thing. We know to go from here to here is pi. Okay. And we know that this amount of angle over here, this is that reference angle, 0.412. So if I want this one, I could do pi minus 0.412 to get that second solution. Now, this was dreadful when I was in high school math, and stupid and dreadful now here. So yes, we can do this old school and find our two solutions, pi minus 0.4, second pi minus minus that answer. And I get the second solution would be 2.730. So I've got these two places, and I'm happy because I know sine is positive twice. Once over here at 2.73 radians, and once here at 0.4 radians. Fabulous. However, yeah, this is really hard for a lot of people's brains. And so I'm going to recommend this. I'm going to recommend that you always check to make sure you're in the right units. And anytime we do anything with a trig graph, you want to be in radians. So what do we have? We have sine theta. And what else did we have? We had 0.4. Now what I'd like to do here is change my viewing window. My x values go from 0 to 2 pi. So let's go to the window. We've got 0. We've got 2 pi. And it really doesn't matter what increments we go up in terms of, you could just leave that as 1. Now, I will say that sine, on our unit circle, sine has the biggest value of 1 and the smallest value of negative 1. So I'm going to make my y min negative 1 and my y max 1. So let's see what happens when we graph this. Here's my sine curve. Can't wait to talk to you about that. That's coming up soon. Oh, look. And here's our line y equals 0.4, and there are two solutions. Second, calculate, intersect. Well, what do we have here? Enter, enter, enter. I get theta equals 2.730. Oh, how cool. And second, calculate, intersect. Bring my cursor closer to that other point of intersection. Where's that gonna be? That's gonna be over here. And I get 0.4115 or 0.412. Ta-da! I think that's a lot less suffering, okay? So, you're welcome to say that the answers are sine inverse of 0.4 and pi minus sine inverse of 0.4. But most people, will have no sense of what those numerical values are. And you're going to have to use your calculator. So why don't you just graph? It's so much easier. Okay. In fact, why don't you do this one? Why don't we say solve on 0 to 2 pi, cosine theta equals negative 0.3. Okay. All right, give it a try. Either method doesn't matter to me. Okay, did you come up with two solutions? You should have answers for x's being negative in quadrant 2 and quadrant 3. So, where are they? Well, I guess we could have written theta equals cosine inverse of negative 0.3. Can I get away with this? Theta equals pi minus cosine inverse of negative 0.3. Let's see if that generates the two answers, because, Kukla's saying, dude, just graph cosine and negative 0.3. Okay, so I got cosine, There's cosine on 0 to 2 pi. I do see two solutions. So I can calculate intersect. I want to bring that close to a point of intersection. Enter, enter, enter. And I get theta equals 4.4076. And if I want to find that other solution, I'm going to bring my cursor close to that other point of intersection. And enter, enter, enter. And I get 1.875489. Okay, so let's check. What's the inverse cosine of, oops, not on that screen. What's the inverse cosine of negative 0.3? Hey, that's this one. This one is cosine inverse negative 0.3. And this one, pi minus inverse cosine of negative 0.3. And I get, oh, that didn't work at all. My second solution was supposed to be this, but I got 1.266. Oh. Well, what? That's very confusing. What am I supposed to, but yeah, and so this is another reason why it's really, please don't do that. You know, if you wanted some sort of honors trig experience, use your reference angles and figure these out properly. But really, we don't need this. This is beautiful. If you could solve this equation by graphing, the ghost of Kukla would be so terribly happy. Okay? All right. There's last thing I want to do with you, though, is some practice. I would like to do some practice of evaluating trig functions at certain points. So, sine of 4 pi over 3. 5, 4, yes, I am counting. You should know this. Think about 4 pi over 3 on the unit circle, and then think about what the y value is there. 5, 4, 3, 2, 1. Did you get negative root 3 over 2? I hope so. Cosine, 7 pi over 4. 5, 4, 3, 2, 1. Cosine is the x. The x value here is positive root 2 over 2. How about tangent of pi over 6? That's a little harder. I'll give you a little more time on that. Five, 4, 3, 2, 1. So I know tangent is sine over cosine. And at pi over 6, sine is 1/2, and cosine is root 3 over 2. So then if I do that flip and multiply thing, I get 1 over root 3. And if I rationalize, I get root 3 over 3. So the tangent of pi over 6 is root 3 over 3. I wouldn't mark 1 over root 3 wrong on one of our tests, but my guess is that, you know, if you take like U of A placement test, you're going to be seeing the situation where they have rationalized everything for you. Okay? All right, so that's those. How about this one? Secant 2 pi over 3. 5, 4, 3, 2, 1. Well, we know cosine of 2 pi over 3 is negative 1/2. And since secant is the reciprocal of this, we have negative 2 over 1, or negative 2. Okay, how about cosecant 11 pi over 6? 5, 4, 3, 2, 1. Okay, so I know sine of 11 pi over 6 is negative 1/2, and cosecant is the reciprocal. So negative 2 over 1 again. And, oh, yeah, no, I'm not going to say that. Cotangent, 5 pi over 4. Cotangent, 5 pi over 4. 5, 4, 3, 2, 1. Well, cotangent is cosine over sine. We know the cosine of 5 pi over 4 is negative root 2 over 2, and we know the sine of 5 pi over 4, third quadrant, so sine is negative as well. And so number divided by itself, almost always 1. The only time, remember, that number divided by itself is not necessarily 1 is when we have 0 over 0. And that'll be a big exploration for us in calculus. Okay, cotangent is positive 1. Fabulous. How about this one? Sine 11 pi over 3. Yeah, bigger than 2 pi. That's right. Mr. Group is not on the unit circle. I understand it's not on the unit circle. It's bigger than 2 pi. In fact, where is it? And this is why I like to use coterminal angles. If I have an angle that's not on my unit circle because it's too big, I want to subtract 2 pi, which is the same as 11 pi over 3 minus 6 pi over 3. I get 5 pi over 3. Oh, so this is going to be just like that. Well, I know the sine of 5 pi over 3. 5 pi over 3 is in fourth quadrant, and the y value there is negative root 3 over 2. And so that's what the sine of 11 pi over 3 is. It's the same thing. Because when I think about the rotation, this is 11 pi over 3. But if I stop here, then I'm only at 5 pi over 3. Okay, so I'm going to be giving you some angles that are too big for our 0 to 2 pi. Cosine 17 pi over 4. What's the cosine of 17 pi over 4? I mean, you already know because it's a pi over 4 that you're going to be getting root 2 over 2 or negative root 2 over 2. All you need to do is figure out whether that should be a positive or negative root 2 over 2. Well, I don't know about 17 pi over 4, but if I subtract 2 pi, which is 8 pi over 4, I get 9 pi over 4. Uh-oh, that's still not on my unit circle. My unit circle stops at 2 pi, which is 8 pi over 4. So if I subtract another 8 pi over 4, I'm going to get pi, 1 pi over 4. So cosine at 1 pi over 4 is positive root 2 over 2. Okay, I think now it's your turn. Secant of 15 pi over 3. Okay, what's the secant of 15 pi over 3? 5, 4, 3, 2, 1. Well, that's way too big. In fact, 15 divided by 3 is 5 pi. Secant of 5 pi. Well, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So here the ordered pair is negative 1, 0. I know that the cosine of 5 pi would be that x value. Secant is the reciprocal of this. So flip, and guess what? Same, negative 1. the secant of 15 pi over 3 is negative 1. You could certainly say, okay, I don't know what that is, but if I subtract 2 pi, I could get to 9 pi over 3. No, it's still not on the unit circle. If I take 9 pi over 3 and subtract 2 pi, I get 3 pi over 3, which is pi. And then I could say, hey, what's the secant of pi? I don't know, but I know the cosine of pi is negative 1, and this thing is the reciprocal. Okay? Okay. How about this one? How about cosecant of 19 pi over 6? 5, 4, 3, 2, 1. So, okay, too big for my unit circle. My unit circle stops at 12 pi over 6. So let's subtract 1 time around the unit circle, and we get 7 pi over 6. Oh, so the cosecant of 19 pi over 6 will be the same as the cosecant of 7 pi over 6. So I know the sine of 7 pi over 6, the y value on the unit circle here, is negative 1/2. That means that cosecant must be the reciprocal of this, or negative 2 over 1. Okay? Cool. So, how about just one more of those? How about cotangent of 13 pi over 6? Cotangent of 13 pi over 6. 5, 4, 3, 2, 1. Well, that's too big for the unit circle. So I'm going to think about 13 pi over 6 minus 2 pi, which is 13 pi over 6 minus 12 pi over 6, or pi over 6. So the cotangent of 13 pi over 6 will be the same as the cotangent of pi over 6. And I know that cotangent is cosine over sine. Cosine of pi over 6 is root 3 over 2. Sine of pi over 6 is 1/2. Root 3 over 2 times flip and multiply. And I get root 3. Our answer is root 3. Cool, cool. So what about these other angles? These angles. Sine of negative 5 pi over 3. Okay, so I could think about that visually. Minus 1 pi over 3, minus 2 pi over 3, minus 3 pi over 3, minus 4 pi over 3, minus 5 pi over 3. Minus 5 pi over 3. And I, since I'm looking for sine, am looking for that y value. Okay, I could do that. What angle had I arrived at? Well, the reference angle, would be pi over 3. But we can get to that same pi over 3, which we do know, and is root 3 over 2. We can get there by using coterminal angles again. If the angle is too big, we subtract 2 pi until we get something on the unit circle. If the angle is too small, we add 2 pi. Minus 5 plus 6 is 1 pi over 3. And that's what we had figured out before. So You can look at it visually. You can use your reference angles. You could use your knowledge of coterminal angles to help you find where on 0 to 2 pi, where on the unit circle you're talking about. Okay? So the sine of negative 5 pi over 3 is positive root 3 over 2. How about this one? Cosine negative 7 pi over 4. Cosine of negative 7 pi over 4. 5, 4. Yeah, oh really? It should go that fast. Yeah. There's negative 7 pi over 4. 3, 2, 1. Did you get root 2 over 2? Well, this is negative 7 pi over 4. Our acute angle here is pi over 4. The cosine of pi over 4 is root 2 over 2. You could also start with negative 7 pi over 4 and say, that's too small. I better add 2 pi. Negative 7 pi over 4 plus 8 pi over 4 is pi over 4. So I can, do this problem any of those ways. If you're a visual learner, if you prefer the coterminal angles, you could even use your reference angles. Could you? Ugh, I feel queasy just thinking about it. Okay, how about the secant of minus pi? What's the secant of minus pi? Well, where are we if we're talking about pi? Here's pi, negative pi, and I want to know the secant there. Well, I know the ordered pair here is negative 1, 0, and I know that the cosine of pi would be negative 1 over 1. So the secant of pi, well, that's just the reciprocal of this. And does it matter that I went this way instead of this way? No, it didn't affect that. But let's test out that theory. Hey, this angle is too small. No worries, mate. Let's add 2 pi to it. Minus pi plus 2 pi is 1 pi. Oh, so if I'm not sure about that one, I can use that one. And that's why I was saying cosine of pi. I was using that coterminal angle that is on the unit circle to help me figure out when this given angle is not on the unit circle. Okay? Okay, so a couple more of these. How about cosecant negative 5 pi over 6? What do you get for cosecant of negative 5 pi over 6? 5, 4, 3, 2, 1. Did you get negative 2? Because I think I did. Let's think about this. So this is my negative angle. And cosecant is going to be 1 over that y value. Well, where am I? If this is negative 5 pi over 6, what's that angle? Well, so negative 5 pi over 6 plus 2 pi is negative 5 pi over 6 plus 12 pi over 6, or 7 pi over 6. This angle is 7 pi over 6. And you should know sine of 7 pi over 6. I don't need you to know cosecant of 7 pi over 6. Start with sine of 7 pi over 6. That's negative 1/2. So the cosecant of 7 pi over 6, well, reciprocal, minus 2 over 1. And what we know is that this angle and this angle have the same cosecant value. So when I'm looking for cosecant negative 5 pi over 6, That's going to be the same as cosecant of 7 pi over 6. This is not on the unit circle. This is on the unit circle. And, in fact, I used sine and then flipped my answer. You can too. All right, how about tangent of negative 13 pi over 3? What do you get? Give it a try. So I'm interested to know what method you used here. What did you do? How did you think about this? Because what I thought about was that's not on the unit circle. Negative 13 pi over 3 plus 6 pi over 3. That's negative 7 pi over 3. Still not on the unit circle. Let's add another 2 pi. No. Negative pi over 3. That's not on the unit circle. Let's add 2 pi. And I get 5 pi over 3. So this is going to be the same as this. Tangent of 5 pi over 3? Not sure. Well, I know that that's going to be the sine of 5 pi over 3 over the cosine of 5 pi over 3. Sine of 5 pi over 3 is negative root 3 over 2. Cosine of 5 pi over 3 is 1/2. And when I do that flip and multiply, I get negative root 3. My answer is negative root 3. Tangent of negative 13 pi over 3, negative root 3. Cool, cool. One more, or are you good? Okay, one more. How about cosecant of 6 pi? Okay, so 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Hey, 6 pi is going to be the same as cosecant of 2 pi. Oh, but since we're going 0 to 2 pi and we're not including 2 pi, we're going to think about cosecant of 0. So the ordered pair here is 1, 0. And I know that cosecant is 1 over that y value. That's undefined. Yeah, turns out cosecant has a vertical asymptote when the angle is 0 or pi or 2 pi. Good. Okay, well, we've done some practicing, and that's kind of cool. You know, if you need more practicing, just let Mr. Paz know, and he'll help you out with that. Have a great day, everyone. In the next video, we're going to start reviewing for the test. Let's review for that test. See you there.